Hello everyone. So my name is Katyayani. So we had started with chapters 12 in the last class, that is vectors and matrices. In the last class we had introduced what are vectors, right? Where are vectors used in the real life? And then we had seen the vectors geometrically. We had seen some operations of vectors like how to add two vectors, how to subtract some vectors. Then there are some rules that vectors follow, that the addition is commutative, there is associative property and so on, right? And then we had done some questions also from the exercise based on the vectors from exercise 12.2 and 12.3. In this class we'll be starting with 12.4, which is about the scalar product of vectors, right? So let's get started. So let's see what is a scalar product with the help of an example, right? So suppose आपके पास एक इंडस्ट्री है, suppose I have an industry जिसमें n products manufacture होते हैं, right? So there's an industry जिसमें n products manufacture होते हैं, right? So there are n products in that industry. Suppose हमारे पास we can denote the quantity of the products by a quantity vector, right? So first product की कितनी quantity है, that is Q1. Second product की कितनी quantity है, Q2, and so on. The nth product की कितनी quantity है, Qn, right? That is being produced. Then we can also have a price vector जिसमें P1 is the price of the first good, P2 is the price of the second good, and so on, and Pn is the price of the nth good. So we have two vectors, Q and P. So now note here that we'll always use an arrow over our vectors because it's very difficult for us to write it in bold here, and so that to distinguish it, we always use an arrow over our vectors, right? So it denotes that Q is a vector, P is a vector. The dot, when I want to find out the total output that is produced in an economy or the total value of the output that is produced in the economy, इसका क्या मतलब है? पहले गुड की Q1 क्वांटिटी प्रोड्यूस होती है, उसका प्राइस P1 है, तो वैल्यू कितनी है उस गुड की? Q1 into P1. Similarly, the value of the second good is Q2 into P2. The value of the nth good is Qn times Pn. If I have to find out the total value of all the products being manufactured in that industry, what will I do? I will take the value of the first product, which is Q1 P1, and then add to it the value of the second product Q2 P2, and so on, and I'll do it till Qn Pn. So this here is called the scalar product of two vectors Q and P. So what is the definition of scalar product? If I want to write it, I can also write it as Qi Pi, where I varies from 1 to n, right? I varies here from 1 to n. So this is scalar product. So we write scalar product is always denoted with a dot in between. So Q dot P is called the scalar product of Q and P, where we are multiplying the corresponding elements of the two vectors. So that is, we are multiplying Q1 with P1, we are multiplying Q2 with P2, and so on, and then we are multiplying Qn with Pn, right? And then we are adding all those corresponding products to get our scalar product, right? So scalar product of Q dot P is equal to summation Qi Pi, where I varies from 1 to n, right? Or you could say that it is equal to Q1 P1 plus Q2 P2 and so on till Qn Pn, right? It is also called the dot product, right? बहुत easy है, देख के पता लगाना है dot product क्यों बोलते हैं, because there is a dot in between. So scalar product is sometimes also called the dot product of two vectors, right? And we can use to find out the wherever we have to find out the product and then add those products, we can use the concept of scalar product in that particular case, right? One thing that you should keep in mind is that the scalar product, that is Q dot P, is defined only when the order of the two vectors is same, right? So defined only when the order is same. If one is an n vector, another one has to be an n vector, तभी हम n corresponding elements को multiply करा सकते हैं, right? So it is defined only when order is same, right? Another thing that you should keep in mind about the scalar product is that the scalar product is not a vector. जब आप इसको multiply करा दोगे, and then when you will finally add it, you will get a number, right? So scalar product is a number and not a vector that you will get. So scalar product of two vectors is always a number. Scalar product of two vectors is a number, right? And how is it obtained? It is obtained by multiplying the corresponding elements. So it is obtained by multiplying the corresponding elements, the corresponding elements of two vectors, right? इसका एक एग्जांपल लेके देखते हैं कि क्या कहना चाह रहे हैं. सपोज हमारे पास एक वेक्टर a है, इट इज 1, -2, 3. दूसरा वेक्टर है हमारे पास b, सपोज वो है -3, 2, 5. Now what is the space in which these vectors are defined? So the space is called Rn. So the real space Rn, right? Rn here stands for the order of the vector or the space in which we are defining that vector. So here you can see that this is three-dimensional space, right? We have x-axis, we have y-axis, and we have z-axis. So here we are dealing with R3. So our space here is R3, right? Now in R3, how can I find the scalar product of A and B? So scalar product is written as A dot B, where I'll multiply A1 with B1. So I will multiply the first element of A with the first element of B, right? So 1 is multiplied with -3, add to it -2 multiplied with 2, and then add to it 3 multiplied by 5, right? And what do you get? You get -3 -4 plus 15, which is nothing but 8. So A dot B, you can see here that A dot B finally that you've got is a number, right? And it is just defined only because the order of the two vectors here is 3 and 3, which is same, right? So this is called the scalar product. कहाँ कहाँ यूज कर सकते हैं हम स्केलर प्रोडक्ट, किस टाइप के क्वेश्चंस कैन बी आस्क्ड? फॉर एग्जांपल लेट मी गिव यू एन एग्जांपल. सपोज देयर इज एक फ्रूट स्टॉल है, राइट? देयर इज अ फ्रूट स्टॉल जिसमें द कमोडिटी वेक्टर, सो देयर आर टू पर्सन्स, पर्सन ए एंड पर्सन बी, राइट? And there are a lot of products that are being sold in that market. Suppose there is cherries, right? Fruit stall hai, cherries are sold. Then there are pears which are sold in the market. Then there are oranges sold in the market. And then finally there are apples, right? The commodity vector is given to you. Commodity vector matlab the commodity vector of A, let's denote it by XA, the quantity of each product that person A buys. Suppose it is given to you as that A buys 3 kgs of cherries, 4 kgs of pears, 3 kgs of oranges, and 5 kgs of apples. It's given to you. Then let X be the commodity vector for individual B, where we are given that B purchases 2 units, 2 kgs of cherries, no pears, then 2 kgs of oranges and 4 kgs of apples, right? So this is the commodity vector for A, this is the commodity vector for B. Then you're also given the price vector, right? So price vector here tells you what is the price of 1 kg of cherries, what is the price of 1 kg of pears, oranges, apples, and so on. So the price vector is given to you as 0.75, 0.60, 0.05, 0.50 and 0.40, suppose. So what does it mean? That the price of cherries is 0.75 per kg. Of course, we're dealing in dollars, so $0.75 per kg. Pears would be valued at $0.60 per kg and so on, right? So ये आपका price vector है यहाँ पे. Now, suppose in the question they ask you what is the cost or what is the total vector that is being bought by A and B, and then what is the cost of that vector. So suppose the question that they want to ask you is what is the total vector being bought, what is the total vector bought by A and B, bought by A and B, and then it is asked what is the cost of the total vector, right? Suppose this is the question that you are asked. So how will you find out a total vector? Total vector is easy. Commodity vector of A plus commodity vector of B. You can add these, and what do you get? You will get 3, 4, 3, 5 added to 2, 0, 2, 4, and then you get 5, 4, 5, 9, right? So that means that 5 kgs of cherries are being bought by both of them, then 4 kgs of pears, 5 kgs of oranges, and then 9 kgs of apples, right? Now, if someone asks you what is the cost, so you multiply the each each commodity or total output of each commodity with the price, right? So here what is needed is the dot product of P and the total vector. So xa plus xb, whatever you have got, the vectors, right? You will take the dot product with the price vector. So what does it mean? So it means you're multiplying 0.75, 0.060, 0.50, and 0.40. You're taking the dot product with 5, 4, 5, and 9. And then, when you're taking the dot product, you have to multiply in the corresponding elements. So when you'll do that, you will multiply 0.75 with 5, then add it to 0.60 into 4, 0.50 into 5, and then 0.40 into 9, right? And the final thing that you'll get would be 12.25. So here you can see that dot product here can be used to find out the total cost of this particular vector, right? So these are some of the applications of the scalar product or the dot product, right, that you might have. Now, there are some operations, or there are some rules that you should keep in mind while doing the scalar products, right? These are very helpful because in this topic, there are certain proofs that are being asked in your exam, right? Sometimes they will ask you what is Cauchy Schwarz inequality, what is the proof for triangles inequality, and so on. तो आपको कुछ basic rules हैं scalar products के जो पता होने चाहिए in order to do those proofs, right? So let's look at some of the properties of, or what are the rules of scalar products, right? So let's look at the rules of the scalar products. Number one, सबसे पहले तो let's define what is our vector. So let A, B and C are n vectors. N vectors मतलब n dimensional space में हम हैं, right? And alpha is a scalar. Scalar मतलब it's a constant. Then what are the rules? Let's see. Number one rule, it's very obvious and easy, is A dot B. If I take the scalar product of A and B, it is same as the scalar product of B and A. So what does it mean? So how can you prove it? The proof is pretty simple. Scalar product of A and B is A1 B1 plus A2 B2, right? And so on till AN BN. And the RHS is B1 A1 plus B2 A2 and so on till Bn An. We know that multiplication is always commutative, so these LHS and RHS here are equal, right? So the proof of the first property or the rule is trivial, that if you take the scalar product of A with B or you take the scalar product of B with A, it is the same thing, right? It is commutative. Now let's look at the second property or second rule of scalar products. The second rule says that if you multiply your vector with a scalar and then take the dot product with the vector b, it is the same as you take the you multiply the vector b with that scalar first and then take the dot product with a. It will give you the same result, right? So again, the proof of this is very trivial. You can try it on your own. The third property is that if I add two vectors b and c and then take the dot product with A, it is the same as me taking the dot product with A and B first, and then A and C first, second, and then adding them. So this is called the distributive law or the distributive property of scalar. So I can distribute A with B and C here. Again, we can see it here in this example. इस एग्जाम्पल में आप देख सकते हो here what I have done is I have added the two commodity vectors A and B first and then multiplied it with P, the price vector. If I would have done it the other way, पहले मैं जो A इंडिविजुअल है उसके प्राइजेस से उसको मल्टीप्लाई करा के A की बंडल की कॉस्ट निकालती and then I would have found out the cost of bundle of of the bundle of individual B and then added that total cost, added those two costs to get a total cost, it would have given me the same result. So मैं क्या बोल रही हूँ, instead of doing this, if I would have done a dot product of P with the bundle of individual A, then the dot product of P with individual of bundle B, and then added them, I would have got the same result, right? So which is intuitive and which makes sense, right? So you can see that the scalar product also follows the distributive property, right? The fourth one is that if I take the dot product of A with itself, right, and it is given to me as positive, then that can happen if and only if A is non-zero, right? So let's look at the proof of this one, right? So this proof might be asked. You might be asked to do this proof, right? So let's prove this. So first thing that you have to keep in mind is that we have a double implication sign here. Double implication का मतलब है you have to go from LHS to RHS. आपको ये use करते हुए इसको prove भी करना आना चाहिए, and then इसको use करते हुए you should reach this conclusion as well. That is if and if, right? So this is a necessary and a sufficient condition, right? So you should go from P to Q and then Q to P, right? The implication is both the sides. So let's see. Let's start with LHS first. So suppose it is given to you that A dot A is greater than 0. इसका क्या मतलब है? Now A dot A का मतलब है, suppose A is an n vector है ये, तो इसका मतलब है A dot A क्या होगा? A का ही product with A. So let me write it first. A1, A2, A3 and so on till An dot A1, A2, A3 and so on till An, right? जब मैं इनका dot product लूंगी, I will multiply A1 with A1, I will multiply A2 with A2, A3 with A3 and then add them all, right? So what do I get? A1 square plus A2 square plus A3 square and so on till An square. If it is given to me as greater than 0, इसका क्या मतलब है? This can happen only when either of कोई ना कोई इनमें से एक A1 या A2 A3 इनमें से कोई ना कोई एक नॉन जीरो होना चाहिए. Only then the sum of these squares would be greater than 0, right? क्योंकि ये नेगेटिव तो कभी नहीं हो सकता because these are squares, पर ये जीरो हो सकता है. जीरो कब हो सकता है? जब सब एलिमेंट्स, सब कंपोनेंट्स A1 भी जीरो हो, A2 भी जीरो हो, A3 भी जीरो, and all of them are zero, right? So for it to be not zero or greater than zero, at least any one of these A's, either A1, A2, कोई भी इनमें से कोई एक नॉन जीरो होना चाहिए, should not be equal to 0. So it implies this can happen only when, so this implies, right? So we are starting from here. So what we are doing is we are starting from here and by implication we are reaching here. So if A dot A is greater than 0, then it implies that either A1 or A2 or and so on, An is not equal to 0, which implies that the entire vector A cannot be 0. So the entire vector A cannot be 0. So now this is, we have gone from LHS to RHS. Now let's start with RHS and then go to LHS. So this is one way. Now the second is if A is not equal to 0. That means if the vector A is not equal to 0, then it implies that the dot product then A1 square plus A2 square plus A3 square and so on A square is not equal to 0, right? अगर ये पूरा A not equal to 0 है, इसका मतलब है इनमें से कोई ना कोई एक A जो है A1, A2 या A3 कोई ना कोई नॉन जीरो होगा, तो जब इनका स्क्वायर का सम करेंगे it will be non zero, which implies that their dot, and what is this? This is nothing but the dot product, so which implies A dot A is not equal to 0. Here you can say that it is not equal to 0, it has to be greater than 0 क्योंकि ये positive है, because these are the squares. अगर ये non zero है तो negative तो नहीं हो सकता, तो positive ही होगा. So this will also be greater than 0. So from here, if A is not 0, then A dot A has to be greater than 0. We have also proved this. So we have proved the double implication. We have gone from LHS to RHS and then from RHS to LHS, starting from LHS to RHS we have reached by the implication, one-sided implication, and then from RHS to LHS also we have reached with one-sided implication, so which implies that the implication is double-sided, right? So that was the fourth rule, that if A dot A is greater than 0, then it implies that A cannot be, the vector A cannot be here, cannot be equal to 0, right? So these are some of the rule of the scalar product, right? Now let's move on to the some geometry, right? कि वेक्टर को कैसे विजुलाइज करना है, कैसे वेक्टर का लेंथ निकालना है. So the next topic that I'll be doing would be how to find out the length of a vector, right? कि एक वेक्टर की लेंथ कैसे निकालनी है. तो सबसे पहले इसको ज्योमेट्रिकली देखने की कोशिश करते हैं. सपोज दिस इज योर, so we are talking about 2D abhi, है ना. So whenever I'm doing it here on the graph paper, it's always convenient to do it in a two-dimensional space with x and y. So I am in the R2 space, real space R2, right? Suppose my vector is A. This is my vector A. This is how I denote A. So the x coordinate here is A1. The y coordinate here is A2. So this length is A2. This length is A1, right? I am interested in finding out the length of the vector. Vector क्या है हमारा, ये है ना vector. तो I am interested in this length. मुझे ये blue वाली length निकालनी है, right? What I'm given is कि ये A2 है, this is A2, right? And this is A1. ये मुझे दिया हुआ है, right? इनकी help से मैं कैसे निकाल सकती हूँ length of A, right? So you can see here that by the Pythagoras theorem, this is 90 degree, right? By the Pythagoras theorem, hypotenuse is equal to perpendicular square plus base square, right? So let's denote the length of A by this sign A norm, right? So in vector algebra, how do you denote the length of a vector? The length of a vector is always denoted by these double absolute signs, right? Double signs. This is called the norm of a vector or the length of a vector. So length or norm एक ही बात है, norm of a vector, or you can also call it the length of a vector A, right? So the length of the vector A in two straight lines is called the norm of the vector. It is denoted by here. What would it be? So base square plus hypotenuse. The base here is A1. Hypotenuse is A2. So A1 square plus A2 square. This is equal to the length square. I want the length, so I'll have to take a square root, right? So it would be A1 square plus A2 square. If I want to generalize it to n space, right? अगर मुझे n space में बात करनी है, तो let A be an n vector, जिसमें A1, A2, A3 and so on are the components of that vector. So right, let A is equal to A1, A2, An in Rn. Then how will you find the length of the vector? The length of vector A, which is defined by A norm, is equal to the dot product of A with A under root, right? So let's see how is it the dot product. So A norm क्या होता है? Dot product जब करोगे A का A के साथ, तो what will it become? A1 square plus A2 square and so on till An square. So can you see that when you're in the Rn space, the formula goes up to n places, right? So यहाँ पे सिर्फ दो space था, तो A1 square plus A2 square under root. Here when you're talking about the n space, the formula for A norm becomes under root A1 square plus A2 square and so on plus An square. That is one way of remembering it. एक तरीका ये है याद करने का, right? You should know this is one way. Another way is you take the dot product and then take the under root. It is the same, one and the same thing, one and the same thing, right? So this is how you find out the length of a vector. I hope you're able to visualize it as well from this diagram, right? So diagram I can only show it to you for two-dimensional spaces, and then you can generalize it for n spaces, right? नाउ ये तो हो गया. अब आपको अगर कोई बोलता है कि मेरे पास दो वेक्टर्स हैं सपोज, और उनके बीच का डिस्टेंस निकालना है, राइट? बिकॉज वी आर इन द यूक्लिड स्पेस, ये जो भी हमारा स्पेस है दैट इज यूक्लिडियन स्पेस. सो द डिस्टेंस इज आल्सो कॉल्ड द यूक्लिडियन डिस्टेंस, राइट? So if someone asks you to find out the Euclidean distance, or simply you can call it distance between two vectors, say A and B, right? So how will you find that? So suppose A एक वेक्टर है, वो भी Rn में है, A1, A2 till An. Rn का मतलब है there are n components here in Rn. B is in the real space with n dimensions, so B1, B2 and so on till Bn, again in Rn, right? You have to find out the Euclidean or the distance between these two vectors A and B. So the formula for it would be, again we denote the distance or the norm by this sign, right? Double absolute signs, right? So which is under root a1 minus b1 square plus a2 minus b2 square, and so on till an minus bn square, right? So it might seem abstract कि ये minus क्यों कर रहे हैं हम. So let me show it to you geometrically for a two-dimensional space, right? So let me show it to you why are we writing this formula like this in a two-dimensional space. Suppose this is our x-axis, this is our y-axis. Vector A is like this, given to you like this. So this is vector A. The coordinates here are A1 and A2, right? The another vector that is given to you is B. Suppose this is your, so this is your B. Suppose this is B. This is vector B, right? The coordinates here would be, so this is B1 and this is B2, right? What do you have to find out? The difference between these two vectors. तो difference कैसे निकालेंगे? हमें क्या निकालना है? A minus B का जो vector होगा उसकी length क्या है? अब A minus B vector कौन सा होगा इसमें? This is the A minus B vector, right? Should always know how to find out, how to denote the difference of two vectors on geometric space. So if this is A vector, this is B vector, right? This is A vector, this is B vector. So उनका difference क्या होगा? The line which joins A and B going till A, right? So this is the vector A minus or B A minus B. तो हमको ये A minus B का norm निकालना है, right? So I want to find out this. I want to find out this line length, okay? ये length निकालना है मुझको. अब you can see that again there is a triangle that is building up here, a right angle triangle, right? I can again find out the length of the hypotenuse by adding the perpendicular square and base square and then taking a square root, right? Now what is the perpendicular here? It is A2 minus B2, you can see here. So this perpendicular is A2 minus B2 and the base is A1 minus B1, right? So again when I have to find out A minus B here, from here you can see that A minus B would be A minus B norm, right? Which is the length of the vectors, of difference of vectors, which is equal to, perpendicular here is A2 minus B2. I have to square it plus the base is A1 minus B1 and then take the under root of it. That is the length of the vector, right? A minus B, which is this vector, right? So I hope you're able to visualize that whenever we have to find out the distance between the difference of two, the length of the difference of two vectors, this is the formula that we'll be using. Generalize करना है, A minus B निकालना है, तो corresponding elements को subtract करके उनका square लेना है and then add that entire thing and then take the square. That is how you can visualize it, and then you can visualize it here in the two-dimensional plane that I have shown you, right? So what have I written? A1 minus, okay, I'm so sorry, A1 minus, again, let me do it again. So the formula was A1 minus B1 square plus A2 minus B2 square. So I'm so sorry. The formula was A1. So you're subtracting A1 and B1, which is the distance base, and the perpendicular is A2 minus B2, right? So perpendicular square from plus base square gives you the length of the hypotenuse, right? So this is how you find out the distance or the length of the difference of two vectors, or the Euclidean distance between two vectors, right? So these are some of the formulas that you should know, because in the questions that these formulas would be tested, right? Another most important topic that is asked that you should know and which is used in many proofs is called the Cauchy Schwarz inequality. So Cauchy Schwarz inequality. The Cauchy Schwarz inequality says that if I take the dot product of A and B and then take the absolute value of that dot product, it will always be less than or equal to the length of those vectors and then multiplying the length of those vectors. So what they are saying is, आप पहले अगर स्केलर प्रोडक्ट ले लो और फिर उसका एब्सोल्यूट वैल्यू निकालो, that will always be less than the individual length or the norms of the vectors multiplied, right? So let's see with an example क्या कहना चाह रहे हैं ये, right? So suppose आपके पास दो vectors हैं a and b, right? Vector a goes like 1 minus 2 3, and vector b suppose है आपके पास -3 2 5, right? If I take the dot product of a and b, it becomes क्या होगा, 1 को मल्टीप्लाई कराओगे -3 से, -2 would be multiplied with 2 and 3 would be multiplied with 5. So 1 into -3 plus -2 into 2 plus 3 into 5, right? So it comes out to be 8, right? Now let's see what is the norm of a. Norm of a का formula क्या था? I have told you it is, the norm of a here is under root a dot a, right? That was the formula for the norm, a under root a dot a, right? So which is nothing but under root a1 square plus a2 square and a3 square, right? So I have to take the square of 1, right? Plus square of 2 would be 4 and square of 3 would be 9, which is nothing but under root 14, right? So this is a norm. Similarly, I can find out b norm. B norm का formula क्या है, हमने लिखा था b dot b, right? Scalar product of b with b under root, यानी b1 square plus b2 square and b3 square under root, which is 3 square is 9, 2 square is 4, 5 square is 25, which is 38, right? So you can see here that b a norm and b norm का product if I take would be under root 14 into under root 38, right? And a dot b we have found out to be 8. You can clearly see that here this a dot b, which is 8, is less than equal to a norm into b norm, right? Because 8 is less than 14 and under root 14 and under root 38. Under root 14 would be somewhat less than 4 but greater than 3. So it would be something greater than 3. This would be something greater than 6. So 3 into 6 would be is 18, and then this has to be something greater than 18. But a dot b we are getting 8, so this uh, is obviously greater than 8, right? So we've proved, right, for this particular set of a and b that the if I take the dot product, then I take the absolute value, it is always less than equal to the product of the norm of those two particular vectors, right? So you'll not be asked to prove the Cauchy Schwarz inequality, but this is something that is useful in another proofs, right? आगे कुछ proofs आते हैं. So in the exam, they are very fond of asking you about the proof of the triangles inequality, right? Triangles inequality से related. So I'll do one version of it, and then there are different versions that are being asked in the exam, right? So उन proofs के लिए Cauchy Schwarz inequality is used. So this is which is used in the background of another proof. So you should know what is a Cauchy Schwarz inequality. It's very important topic, a very important topic from this particular section, right? So अब हम देख लेते हैं कि Cauchy Schwarz inequality actual में use कहाँ होती है, right? So let's see where is this Cauchy Schwarz inequality useful. So it is useful to prove the triangles inequality for vectors. So useful to prove triangles inequality for vectors, right? तो देखते हैं कैसे होगा. So सबसे पहले let me give you the geometric meaning कि हम geometrically क्या prove करना चाहते हैं. Triangles inequality होती क्या है? Geometrically what do you want to prove? And then in the exam they will ask you the mathematical proof of it, right? So first I want to show it to you that what does it mean geometrically. So let's see. Suppose आपके पास एक xy plane है. This is your xy plane. X and y, right? This is your vector A. right? This is vector A. We have another vector B, right? B starts from here and goes say up to till here. This is vector B. Now what will be A minus B? If this is vector A, this is vector B, right? So what will be, what will be A plus B? So if I add these two vectors, what would be the sum of these two vectors? It would go from origin to here, right? This we have already proved that how do you show the sum of two vectors on the geometric plane. So this is A plus B. Triangles inequality says that the length of this vector A plus B is, so triangles inequality says that the length of the vector A plus B, so to denote length we are using the sign A plus B, is always less than equal to the length of vector A plus the length of vector B. This is the simple triangles inequality that you've already done in your geometry courses in the uh, in 10th and 11th 9th standard, I think, right? So what does it say? हमने पढ़ा था कि कोई भी triangle की the sum the length of the third side of a triangle is always less than or equal to the sum of the other two sides, right? This we have already proved, this we have already seen in geometry, right? Now how do we use it in वेक्टर फॉर्म, राइट? वेक्टर्स में हम कैसे प्रूव करेंगे कि अगर हमारे पास दो वेक्टर्स है ए और बी और अगर मैं उनका सम लूं ए प्लस बी, देन द लेंथ ऑफ दैट वेक्टर ए प्लस बी हैज टू बी ऑलवेज लेस देन इक्वल टू वेक्टर ए, the length of vector a plus the length of vector b. So we have to prove that this length here, where is my highlighter here? So this length here is less than the sum of these two lengths, this plus this, right? So जो blue वाली length है, it is less than this yellow length, right? Sum of vector a, length of vector a and length of vector b. This is what you have to prove. Now the geometric interpretation of it is clear. Now let's go to the maths of it, right? अब maths करते हैं. Geometrically आपको समझ आ गया हमें prove क्या करना है. This is called the triangles inequality for vectors, right? So let's start with LHS. LHS से start करते हैं. तो सबसे पहले हम क्या करेंगे, a plus b दो वेक्टर्स हैं, इनके नॉर्म का स्क्वायर ले लेते हैं. लेट्स टेक द स्क्वायर ऑफ द नॉर्म. यू नो दैट दिस इज इक्वल टू, सो दिस इज इक्वल टू, जो नॉर्म होता है वो अंडर रूट के इक्वल होता है, इसमें हमने स्क्वायर लिया तो बेसिकली वी हैव टेकन दिस स्क्वायर टू गेट रिड ऑफ द स्क्वायर रूट साइन. ठीक है, वी डोंट वांट टू डील विद द स्क्वायर रूट साइन, तो इसीलिए हमने स्क्वायर ले लिया है यहाँ पे. तो दिस इज इक्वल टू a प्लस b वेक्टर का डॉट प्रोडक्ट विद a प्लस b वेक्टर, राइट? क्योंकि हमें अगर नॉर्म निकालना है तो उस वेक्टर का डॉट प्रोडक्ट लेना पड़ता है खुद के साथ. तो हियर द वी हैव टू फाइंड आउट द लेंथ ऑफ a प्लस b, तो a प्लस b का डॉट प्रोडक्ट लेना है विद a प्लस b itself. Now the distributive law says that this is equal to, so I can take the dot product of a with a plus b and then the dot product of b with a plus b. So what I can do is take the dot product of a with a plus b and then plus take the dot product of b with a plus b. So you have to write a dot in between. Now when I open this, the distributive law says that a dot a plus a dot b, right? This becomes b dot a plus b dot b, right? Now you know that since we have already proven that we have already seen that a dot b is nothing but b dot a. Commutative होता है तो a dot a b और b dot a एक ही बात है, right? So these are nothing but the same thing. So I can write it as a dot a plus 2 times a dot b plus b dot b, right? Okay, so we've reached till here. Now let's see. A dot a. A dot a, can I write it as a norm का square? Right? I can do that, right? Because a norm is under root a dot a. So a norm का square would be a dot a. Then let's write it like this only abhi. And then b dot b को I can write as b norm square. Right? Now you know that अगर मैं दो वेक्टर्स का डॉट प्रोडक्ट लेती हूँ, इट कैन बी पॉजिटिव, इट कैन बी नेगेटिव, राइट? ए और बी वेक्टर्स हमें पता नहीं क्या है, पर उनका जो डॉट प्रोडक्ट है इट कैन ऑलवेज बी नेगेटिव. बट द एब्सोल्यूट वैल्यू is always positive. तो अगर a dot b 0 है तो absolute value और the actual value is the same. But अगर a dot b positive negative है, then the absolute value of a dot b would be greater than a dot b. So we always know that a dot b is always less than equal to the absolute value of a dot b, right? Because a dot b negative हो सकता है, but absolute value ले लोगे अगर a dot b की, so it will always be positive. So a dot b is always less than equal to the absolute value of a dot b. So I can write it as this entire thing would be less than equal to a norm square plus 2 times absolute value of a dot b plus b norm square, right? Everything else is same, but मैंने इसकी जगह a dot b की जगह I've written the a absolute value, and I know that it is always absolute value is always greater than equal to the actual value, right? Now अब ये याद करो Cauchy Schwarz inequalities के बारे में क्या कहती है. Cauchy Schwarz inequality says, we've already seen that the a dot b absolute value is less than equal to this, right? So what I can do is here I can replace it, this a dot b, so this entire thing would be less than equal to a, right, again by the Cauchy Schwarz inequality, plus 2 times a norm into b norm plus b norm square. And how do you get it? By Cauchy Schwarz inequality, right? Cauchy Schwarz inequality. Is it clear to everyone? Yes. So now can you see that, do you see a pattern here कि a norm का square है, then a norm है, b norm है, then b norm square. So is it the formula for the square of a plus a norm plus b norm, right? Yes. So you've always put these signs here. So this is nothing but equal to a norm plus b norm square, right? So you can see we started from here और हम कहाँ पहुँच गए हैं, that this a plus b norm का square is less than equal to a norm plus b norm whole square, right? Now if I take the square root on both sides, so taking square root on both sides, what do I get? Taking square root on both sides, this is a plus b norm is less than equal to a norm plus b norm, and this is what we had to prove. The triangle inequality is proved. So this is hence proved, right? This is also a question from your exercise जो मैंने आपको कराया है. This is exercise 12.4 का question number 8 it is, right? So these type of questions are also given in your exercise, और इसके अलावा these type of questions are asked a lot in your exams, right? इसके कुछ ना कुछ different versions are being asked in the exam. So the idea remains the same. अगर आपको ये proof समझ आ गया, you can do the other proofs as well. So just go over it again or once again. This is very important from your examination point of view, right? So this is called the triangles inequality for vectors, right? And you have also seen how to visualize it, that the third side is always less than equal to the sum of the other two sides, right? और ये हमने ज्योमेट्री में ऑलरेडी किया हुआ है. इसको हमने वेक्टर के टर्म्स में we've written it in the terms of vector. That is what it is called triangles inequality in vectors, right? So is it clear? I hope it is clear. I hope it is going good till now, right? We have done a lot of concepts, right? We have seen also that उसको geometrically कैसे prove कर सकते हैं, right? So I hope you're finding it very interesting. We are doing questions also along with the lecture, right? So the next topic, अब इसके बाद एक topic बचता है जो हमें करना है, that is called the orthogonality of two vectors, right? So what is orthogonality of two vectors, right? So let's look at the orthogonality of vectors, right? Suppose आपके पास दो vectors हैं a and b, a vector और b vector. Orthogonal का मतलब होता है they are perpendicular to each other. We say that a and b अगर दो vectors perpendicular हैं एक दूसरे के, then it implies, so there is double implication that the dot product has to be 0. The proof of it is also asked sometime in the exam. But orthogonality की simple definition है कि अगर दो vectors आपस में perpendicular हैं, then उनका dot product zero होगा ही होगा. It is also the other way around. अगर दो vectors का dot product zero है, तो वो orthogonal होंगे ही होंगे. So you have to keep in mind that this is a sufficient and necessary condition. The implication is both the ways. There is double implication. अगर orthogonal है तो dot product zero होगा ही होगा. अगर dot product zero है तो वो orthogonal होंगे ही होंगे. This is called the orthogonality of two vectors, right? So अब इसको prove कैसे करना है? Again, दोबारा ज्योमेट्रिकली देखते हैं, राइट? सी ज्योमेट्री मेक्स इट वेरी इजी टू एनालाइज. ये जब अगर आप ऐसे करोगे, इफ यू डू द प्रूफ्स मैथमेटिकली ऐसे ही, देन द थिंग्स बिकम वेरी एब्स्ट्रैक्ट कि क्या कर रहे हैं, क्या चल रहा है, यू नॉट एबल टू इमेजिन इट, राइट? व्हेन यू डू इट ज्योमेट्रिकली, जब आप उसका ग्राफ देखते हो क्या हो रहा है, देन इट गेट्स सेटल्ड इन योर हेड, राइट? सो सपोज आपके पास एक्स वाई प्लेन है अगेन, राइट? आपका एक वेक्टर है ए वेक्टर, अनदर वेक्टर इज बी वेक्टर, right? This is a vector, this is v vector. Then a minus b क्या होगा? This is a minus b. Just give me a minute. The a minus b vector would be, this would be a minus b vector going from b to a. Right? So this is a minus b vector. Now we have to prove that this is 90 degree. ठीक है? थीटा अगर 90 डिग्री है, then इनका जो डॉट प्रोडक्ट है ए और बी का, ये हमेशा जीरो हो. दिस इज व्हाट यू हैव टू प्रूव. एंड द अदर वे अराउंड आल्सो कि अगर इनका डॉट प्रोडक्ट जीरो है, देन द वेक्टर्स वुड बी ऑर्थोगोनल, राइट? तो देखते हैं कि क्या करना है इसमें. लेट्स name this triangle as O, A and B, right? The points of this triangle are O and B. This is the vector A, this is the vector A, this is the vector B, and this is the vector A minus B, right? अब पाइथागोरस थ्योरम क्या कहती है? So by पाइथागोरस थ्योरम, पाइथागोरस थ्योरम बोलती है कि अगर ये 90 डिग्री है, if this theta is 90 degree, if the angle between them is 90 degree, then the hypotenuse would be equal to hypotenuse square would be equal to perpendicular square and plus base square, right? So the Pythagoras theorem says that if theta is equal to 90 degree, right? So theta, the Pythagoras theorem says that theta is 90 degree if and only if and only if. Pythagoras theorem में भी हमेशा double implication होता है, keep in mind. So Pythagoras theorem says that theta is 90 degree, this theta is 90 degree if and only if OA square plus OB square is equal to AB square, right? बेस प्लस परपेंडिकुलर का स्क्वायर, बेस का स्क्वायर प्लस परपेंडिकुलर का स्क्वायर इज इक्वल टू हाइपोटेन्यूज स्क्वायर. तो इन दोनों के बीच का डिस्टेंस 90 डिग्री तभी होगा इफ एंड ओनली इफ दिस इज इक्वल टू दिस. नाउ व्हाट इज OA? दिस इज A नॉर्म का स्क्वायर, राइट? व्हाट इज OB? दिस इज B नॉर्म. B नॉर्म मतलब लेंथ ऑफ वेक्टर B का स्क्वायर. एंड देन AB इज A माइनस B जो है, यानी लेंथ ऑफ वेक्टर A माइनस B नॉर्म. लेंथ को हम नॉर्म भी बोलते हैं, स्क्वायर, राइट? So theta is 90 degree if and only if this condition holds, right? Now इसको आगे लिख लेते हैं. theta is equal to 90 degree if and only if. अब इस चीज को मैं कैसे लिख सकती हूँ? A norm square is nothing but this dot product of A with A, right? See, this definition is very important. ये बार बार यूज हो रही है. You can see that A norm को हम कैसे लिखते हैं? A dot A यानी स्केलर प्रोडक्ट ऑफ A with itself का अंडर रूट. यहाँ पे स्क्वायर है इसलिए अंडर रूट गायब हो गया. सो A नॉट, इसी चीज को मैं दोबारा से लिख रही हूँ. तो A norm square which is A dot A plus B norm square is B dot B is equal to A minus B dot A minus B. Again when you will open this, we have already proven this. A dot A बन जाएगा minus 2A dot B बन जाएगा and this would become B dot B, right? When you will open this, this is what you will get. तो बोल रहा है कि थीटा 90 डिग्री तभी होगा when this is equal to this LHS is equal to RHS. अभी LHS RHS कब इक्वल हो सकते हैं? देखो LHS में सिर्फ हमारे पास A dot A और B dot B है, पर RHS में हमारे पास एक एडिशनल टर्म है. तो इन दोनों की इक्वालिटी के लिए A dot B क्या होना चाहिए? 0 होना चाहिए. तो थीटा is equal to 90 डिग्री if and only if A dot B is equal to 0, Right, so have you proven this? तो हमने प्रूव कर दिया कि थीटा 90 डिग्री तभी होगा जब ये इक्वालिटी होल्ड करेगी. दिस इक्वालिटी, दिस एंटायर इक्वालिटी विल होल्ड. तो हमने प्रूव कर लिया कि द थीटा वुड बी इक्वल टू 90 डिग्री ओनली इफ दिस इक्वालिटी होल्ड्स. राइट, और ये इक्वालिटी कब होल्ड करेगी? जब ये वाली टर्म ना हो. एंड व्हाट इज दिस टर्म? ए डॉट बी. तो ए डॉट बी अगर जीरो होगा, ओनली देन वी कैन से दैट थीटा इज इक्वल टू 90 डिग्री. राइट, तो दिस इज डबल इंप्लीकेशन. कीप इन माइंड दैट वी आर ऑलवेज वर्किंग विद. अभी यहाँ पे हमने स्टार्टिंग डबल इंप्लीकेशन से किया था. राइट, सो ऑर्थोगोनैलिटी क्या कहती है कि दो वेक्टर्स के बीच का सम, दो वेक्टर्स के बीच का एंगल वुड बी 90 डिग्री इफ एंड ओनली इफ उनका स्केलर प्रोडक्ट इज जीरो. सो वी हैव प्रूवन द orthogonality of the two vectors here. Right, now इसमें से there are some questions that can be asked from this topic. So let's do one question from your exercise. So we are doing exercise 12.4. This is question number 3. The question number 3 here says that check if 1 minus 1 1, which is, let's call it vector A is orthogonal to vector B. Let's define B as minus 1 1 and minus 1. You have to tell me whether they are orthogonal or not. तो अभी मैंने आपको बताया कि orthogonal है अगर तो उनका dot product 0 होना ही चाहिए. So easy way for us to check whether the two vectors are orthogonal or not is to find out their scalar product. अगर scalar product 0 आ रहा है then the vectors are orthogonal to each other. Right, so let's find out the dot product. Dot product या scalar product, it's very easy. You will multiply the corresponding elements and then add the products. Right, so 1 divided by minus 1 is minus 1, minus 1 divided by 1 is again minus 1, and then 1 divided by minus 1, you get minus 3, which is not equal to 0. So you can safely say that A and B here are not orthogonal because their dot product is not equal to 0. Right, so this was question number 3. और किस टाइप के क्वेश्चंस पूछे जा सकते हैं इसमें? Let's do another question from the same exercise, question number 5. It says for what values of x are, so there are two vectors A. Vector A is x minus 8, x comma x. So there is this one vector R4 में है. देखो, there are 4 elements here. So we are defining the vector in real space with 4 dimension, right? R4. And another vector, say let's call it B, is x1 minus 2 1 orthogonal. तो किन x की वैल्यू के लिए ये दो वेक्टर्स आपस में ऑर्थोगोनल है? सो दे विल बी ऑर्थोगोनल ओनली व्हेन देयर डॉट प्रोडक्ट इज 0. तो हमें क्या करना है? सिंपली वी हैव टू पुट द डॉट प्रोडक्ट एज 0. सो लेट्स डू इट विद अनदर कलर पेन. सो वी हैव टू पुट द डॉट प्रोडक्ट एज 0. सो दे विल बी ऑर्थोगोनल. A and B will be orthogonal if and only if A dot B is equal to 0. So let's put A dot B as 0. So x multiplied by x is x square minus x minus 8, and then x is multiplied with minus 2 is minus 2x plus x is equal to 0. So you get x square minus 2x plus 8 is equal to 0. So it is x square minus 4x. So middle term split करेंगे. So this is what you will get. So sorry, this is minus here, minus again, minus here. Right, this is equal to 0. So what do you get? X minus 4 plus 2 x minus 4 is equal to 0. So x plus 2 and x minus 4 is equal to 0, which implies x is equal to minus 2 and x is equal to 4. So these are the values of x for which the two vectors are orthogonal, right? So this is easy concept, right? These are type of questions that are asked from these topics, right? What you can do is you can try other questions from the exercise, and also at the end of the chapter we'll be doing some questions from these topics that are being asked in the past year exams also, so that you get an idea कि किस type के questions आ सकते हैं. Before that, you do all the examples that are there in your book, and then also do the questions that are given in your book. So I hope this topic is clear, orthogonality, right? With this we are done with section 12.4 of your book, Etc. and Hammett.